In today's math lesson, we are going to work on 3 different parts in Unit 6. And the first part, I can define and measure parallelograms. So let's think back to parallel lines. What are parallel lines? They are lines that never meet or cross. They are always the same distance apart. So you can see the picture here with these 2 lines. You can see that these 2 lines will never cross. They'll never meet. And then I love this picture here to also show that the 2 L's standing next to each other are also parallel lines. Some other things that I can think of is a window. So maybe if you look at a window and you look at the left side of the window and the right side of the window, those lines are parallel. Another idea that I came up with for, so windows and highways are also parallel lines, because if you think of a highway and there's cars going one way and the other cars are going the other way, those cars will never cross paths because those highways are parallel lines. So now that we've reviewed what parallel lines are, what is a parallelogram? A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. So keep in mind, a quadrilateral is just a 4-sided polygon, and a parallelogram is when the opposite sides, so these 2 sides in the square are opposite, they're parallel to each other. This line here and this line here, they're opposite of each other and they're parallel. If we look at the next shape of the rectangle, these opposite sides are parallel and the opposite sides here are parallel. And even if we look at this shape here, the line here and here, it is parallel to each other. And these 2 lines are also parallel to each other. That's a parallelogram. So a parallelogram is a quadrilateral with 2 pairs of parallel lines. And then we have a picture, and you can see they showed an eraser. So we could say an eraser is a parallelogram. And this shape is a parallelogram because there are 2 pairs of parallel lines. So the first page that we're going to work on is page 467. We're going to skip this slide, and we're going to kind of zero in on the top portion of page 463. I may have said the wrong page number, but it's 463. And up here at the top, all of these are parallelograms, and the reason for that is the opposite sides are parallel to each other. And if you look at the bottom and the top, those 2 lines, if they were extended, they would never cross or touch each other. Same with letter B. They're perfectly parallel. Even C, you can see that these lines will never cross. And this pair of lines will never cross. So you can see rectangles, squares, and parallelograms all fit into this category. If you look at the next set of these purple shapes, these are not parallelograms because they do not have 2 sets of parallel lines. So let's focus in on F. So you can see eventually if you extended these lines, eventually they would cross. Same here. I'll do this one in black, Eden Prairie colors. These 2 would eventually cross. Let's look at G. This line and this line would eventually cross up towards the top. So the letter G is interesting because letter G just has 1 set of parallel lines. So 1 set of parallel lines is not enough to make it a parallelogram. you have to have two sets of parallel lines. And you can see if you extended this one, these are going to cross, and these already cross here. So on this one, again, look at one set of parallel lines, but this one right here, it's going to cross. And this hexagon, eventually, these sides, well, the reason this hexagon is not a parallelogram is because it needs to have 4 sides. So that's the reason that the hexagon cannot be a parallelogram. So a parallelogram is a quadrilateral with opposite sides that are parallel. So in other words, a parallelogram has to have 2 sets of parallel lines. And I'm going to make this parallel lines. That's my symbol for parallel. Okay, at the bottom here, they want us to measure these sides, and then they want us to examine at the lengths and figure out the patterns that we are seeing. Since we're kind of past our measurement unit, I'm going to give you what the sides are. This side is 3, this side is 4 centimeters, this side is 3, and of course if the top is 4, the bottom is 4. On this shape, this is 2 centimeters, therefore this is 3 centimeters, therefore this is 3 centimeters. So when you look at number 2 and number 3, what patterns do you notice? I'll give you a second to think about that. Hopefully you said the opposite sides are parallel. So that is what I wanted you to notice there. The next part of our lesson is this. I can describe and relate rectangles, squares, and rhombuses by using reasoning and precise language. So let's look at these shapes at the top of page 464. And they're asking us, is Adele right? Describe the rectangles. All of these figures are rectangles. Rectangles have adjacent sides that are perpendicular. And maybe you recall, adjacent is when 2 sides meet each other at a corner. So perpendicular is this exact thing, when they meet at a corner. So Adele said rectangles are special kinds of parallelograms. So what do you think? Do you think Adele is right? Yes, he is right. And the reason a rectangle is a parallelogram is because it has 4 right angles. So let's look at those angles. And I know that you studied angles in lesson 5. So here's the angles. It's when 2 sides come together. And you can see on all of these shapes, these are all right angles. So it's a 90-degree angle. If you put a piece of paper or a Post-it up to these shapes, it would make a perfect corner at 90 degrees. Explore squares and rhombuses. These figures are squares, so the yellow ones are squares. These figures are rhombuses. Okay, so you can see we have a square can also be a rhombus. So Takeshi says squares are special kinds of rectangles. Cora said rhombuses are special kinds of parallelograms. And yes, they are. A square is a rectangle because the sides are always the same length. Also, you should know that a square is a rectangle because another reason is because a square has two sets of parallel lines. A rhombus is a parallelogram with sides that are all the same length. A rectangle is a parallelogram with four right angles. And when we talk about opposite, keep a track that this side is opposite of this side, whereas the top is opposite from the bottom. So this rectangle has four right angles. Here's the last part of lesson 6. I can use structure to define trapezoids and identify the names for given quadrilaterals. So a quadrilateral is a polygon with four sides. And you can see there are all these different pictures of quadrilaterals. They are all quadrilaterals because they have four sides. As long as the side is closed and the sides are straight, I know my picture isn't perfect, it is a quadrilateral. This one is not because it's not closed. This one is not because it's five sides, so it has to have four sides. Blank is a quadrilateral. Well, if you look at the cover of a book cover is a quadrilateral. And this shape is a quadrilateral because it has four sides.